This is to capture all the pressure buildup events when these ESP wells from Harbour, the same field, shut in, right? So here's the dashboard that I'm going to talk about. As you can see, it's got a table as well that you can sort according to well, to latest buildup. You can also drill down into the different trends that show the buildup. That's loading there. Okay, so I can zoom into these. I'll get into a lot more detail once I finish my presentation on how this works. So what is this? So it's a pressure buildup dashboard. We work with the engineers in Harbour in the Mittelplatte field. It automatically identifies well shut-in events by tracking the ESP power tag. So when the power goes to zero, there's a shutdown of the well, and that's when the script kicks in. So we capture that pressure buildup from the beginning, from the time the well was shut in until it starts again, okay? Those results are tabulated in a sortable table that has links to the real-time event. And it also, there's another function that allows the user to download all the events for all the wells with a single click. Now, demonstrate that. So why is this useful? Why is it necessary? Well, wells are shutting in all the time, but these present an opportunity to capture the pressure buildup, which is used for reservoir characterization. So reservoir engineers really relish the possibility to capture the profile and the data that represents the pressure buildup, alongside with other data that is used to characterize the reservoir. Obviously, the steady stable pressure after this event is obviously the reservoir pressure that well is seeing, which is another key piece of information for reservoir monitoring, reservoir management. So it's very valuable. Now, these events were possibly being lost or within the sea of data. They were not being, the data was not being captured in a way that could be used. And obviously this dashboard enables that, right? Okay, so how does it work? Similar pattern to the ESP event. There's an event that gets generated when the ESP stops and the ESP restarts. So it's a beginning and end type event using user-defined alerts. At midnight, there's a script that runs and checks for all the events and critically updates the CSV files that contain all the PBU events. Why do we do this? Because we don't want the user to wait for all the data to be compiled when he wants to download the CSV file for all the events. So it gets updated day by day, okay? So that creates a very easy, a very quick response for the user. Now, we take the well name of that event that happened and create, again, we create a PBU event, so pressure buildup event that we store back into the event, into Elastic, that will support data visualization. And in doing this, we access the knowledge graph through the well name, which is the link to obtain the ESP power, the ESP inlet pressure, so the pressure, the oil rate, and the water rate from the latest well test that we have associated to that well. All that data is connected in the knowledge graph through the well name that we captured. So then now, again, through a Node-RED script, that turns that information into an API response in the same way that Andrew showed. That API is then accessed by a dynamic dashboard that will visualize the data, again, with a similar structure to the ESP frequency change. Okay, and this is, the Node-RED that powers that dashboard. Again, similar structure, very easy to configure. The engineers configure this and it's running immediately, which is a great advantage. And we can see that in the demo. And this is, I'll show this. This is how the component is connected to the API to show that data. So moving on to the example, I had drilled down into that event. Obviously this, I can zoom in. This is a fully functional trend that I can go through and I can examine the event. Obviously, these are the other events for the same well. Okay, if I want to go back to another event, I can also go back to the overview. This, again, as I mentioned, you can go by well, you can go by the latest buildup. If we look at the latest, it's actually in September, the 19th of September, and it's lasted 37 minutes, 0.37 hours. And here's the button to generate the CSV. So basically click on it and I get a download, click on it, and we'll open it. So this is a CSV that contains, as per the spec from the user, this contains all the events that we have access to. And we can identify the different events because they have the same end and start time. So if I color this, that's one event for Weld DS2. And here's another event for Weld DS2 that finishes there. So you can see the different events. And then, so it goes DS2, DS3, et cetera, et cetera. If you look at this file, it's got 24,881 rows, okay? So that's all the data. Obviously, that could be fed into, analysis software that will take the information to perform, reservoir characterization, whatever is necessary. So the columns we have is the well, the date and time, the pressure, every hour in this case, the oil rate and water rate, which is, again, it's discontinuous. It comes from the well tests. And then the event start and end, which is the same for all, okay? So yeah. Okay, so that's all I had.